Hello and welcome to today's video where we will be learning how to use LEDs with the Raspberry Pi Pico. We will look at the onboard LED, wiring an LED and coding it with MicroPython. For this we will be using Thonny. If you do not already have this, check out our video showing you how to download it and get started with it by clicking on the card above. First, we need to change the Python interpreter from the default to MicroPython. Go ahead and plug your Pico into any available USB port on your PC, making sure the other end of the wire is connected to the micro USB port on the Pico. After this, Thonny will be able to see the Pico, so you can select where it says your Python version at the bottom right and select MicroPython, Raspberry Pi Pico. Now we can begin our programming. We are going to begin our code by importing the needed library by typing from machine import pin. Ensure pin has a capital P, the rest should be lowercase. We will begin by just using the onboard LED on the Pico. You can find this near the USB port, as can be seen in this image on screen. Now we are going to define what our LED is to Python. On a new line, type a name for your LED. I am just going to call it this, but I will use all lowercase to make it easier for me to type later on. We are then going to put a space equals, then another space, then type pin with a capital P. Bracket. We will then type the pin our LED is connected to, as we are using the onboard LED type 25, as this is the number pin it is connected to. Then straight after 25 put a comma and then another space. We will now finally type pin with a capital P.OUT, without being all in capital letters. Now end this with another bracket. Now on a new line type the name you defined. This is what you put before the equal sign on the previous line, and then type dot on with brackets with nothing inside. Now we can click run. Once we do this, Thonny will ask us to save the document. Click Raspberry Pi Pico to save it to the device and then type a file name and end it with .py. Now as soon as you click OK, the file should be saved to your Pico and should run. You should now see the green LED light up, as can be seen on my Pico here. To turn it back off, just replace on the last line with off and click run. Once you click run, Python will automatically save these changes over the previous version, so you won't need to save again. As can be seen here, the LED will now turn off. Now let's learn how to use a physical LED instead of the onboard LED. You will need to ensure you have headers soldered onto your Pico for this. I also would recommend a breadboard, however you can just connect jumper wires. I would personally recommend the breadboard I am using here, that has the Pin.OUT of the Pico already printed on it. Links to this item can be found on the card above now or down in the description, alongside other items I used for this project. If you do not have this breadboard and you are unsure of which pins do what, I have included a link to the Raspberry Pi documentation down in the description below or the card up above here. On this page, near the top just a little down, there is a Pin.OUT that you can download if you wish. This shows what every pin is and some extra things such as the onboard LED. You will also now need two male-to-male jumper leads, an LED of your choice. I am using a blue one. You will also need a 330 ohm resistor. If you look at your LED, one of the legs at the bottom is longer than the other one. The longer one is the positive anode and the short leg is the negative cathode. If you are not sure how your breadboard works or what is connected, go ahead and pause the video now to see how your breadboard is connected. If you do already know, just continue watching. Before building this circuit, ensure you unplug the Pico from your computer. Go ahead and put your LED under the Pico. Make sure that the two legs are on different rows so they are not shorted, and ensure that you remember which hole the short and long leg is in. If you connect the LED up the wrong way, it won't damage it, just it won't light up. My anode or the longer leg is in row 30 here, with my shorter leg or the cathode in 29. Next up we are going to get our 330 ohm resistor and connect one side to the row your anode, or longer leg is on. A side of the resistor can be connected here. You actually can also put your resistor on the other side of the LED, but in order to keep this tutorial easy to follow, I recommend you connect it the same way as shown here in the video. Next, put the other leg of the resistor on any other spare row on the breadboard that has nothing connected to it. Now we are going to need our two jumper wires to connect our LED up to the Pico. Take one side of your male-to-male jumper wire and connect it to the same row that the shorter leg or cathode of your LED is connected to. This shorter leg is ground. We can now connect the other side of this wire to any pin of our Pico that is ground. If you are using the breadboard that I am, you will see this labeled with a G. Now, connect another male-to-male jumper wire to the row that the other end of your resistor is connected to. Connect this jumper wire to any numbered GPIO pin of your Pico. Here, I am going to connect this to pin 16. I recommend you do this too to make following the code easier. Pin 16 is the pin at the very bottom of your Pico, the other side of the USB, on the right hand side. I am now showing a circuit diagram for how to connect this up. Now you have wired up the LED, let's jump back to Thonny. On our code, ensure our last line is still dot on rather than dot off. If it is dot off, change it back to dot on. Now we are going to tell Python the new pin that the LED is connected to. Delete 25 where we have defined our LED and replace it with the numbered pin you connected the LED to. If you wired it up as I did, that will be pin 16. We are now ready to run our code, however you may have noticed the run button is grayed out and there is a message in the shell. This is because we disconnected the Pico to build our circuit. Ensure the Pico is plugged back into the computer and click the restart button. This is the last button on the row of buttons. Once you do this, the shell should refresh and you should be ready. Go ahead and click run and then you should see your LED light up. If it does not, then make sure your code is correct, as even a space can cause Python to not be able to read the code. If that is correct, ensure that your LED's legs are the correct way. Remember, the shorter leg should go to ground. If that is correct, make sure all your wires are connected, and if they are, try a new LED, resistor or wires until you find the issue. To turn it off, just change your code to dot off like we did for the onboard LED. Finally, the last part to this video is showing you how to run the code without your Pico being connected to a PC. If you want any code to run on your Pico without it having to be connected to a PC, just follow this. Save your file. I am just going to copy and paste my code into a new file to make it easy to resave, as main.py. When your Pico receives power, it will then know to run this. To test this, disconnect your Pico from your PC and plug it into a wall socket or a power bank. You should now see your code runs. Watch as I turn this outlet on and you will see the code run. You can see the wire here is connected directly to the outlet with no external PC connected. If you would like a challenge to test out your learning, try and create a new file to run your LED and the onboard LED at the same time. You can then also attempt to run this without your Pico connected to the PC. I will include what you need to do this in the description down below. Leave a comment if you successfully did this. Make sure to like the video if you found it useful. If you have any questions, feel free to leave it in the comments down below. Subscribe to the channel and press that bell icon so you do not miss any future videos. Make sure to also check out our social media pages using the links in the description. Thanks for watching.